you, James.
All right, friends, we are back in action doing everyone's favorite thing, some geometry proofs here. I'm going to work through each one of these at a semi-fast pace. Obviously, come in for tutoring if you still are struggling. This is hard for everybody, though. As I mentioned in class, proofs require you to understand geometry really, really well and have strong, I call it logical sequencing skills. And most people don't have that. What do I know? How do I know it? What does it mean? These are all things that you have to understand, and that is hard. So with that said, I'm going to go through and do these proofs the way that in a way that maybe is helpful for you. All right, so the first one, we highlight things that we know, and we mark things that we want with different colors. So J and K are parallel. That's a big deal. We should already be thinking, what do I know because of those parallel lines? And they told us angle 5, I'm going to put a mark with a dash, is equal to angle 6, a mark with a dash. Those are things that we know are true. We don't have to prove that those are true. We were told they were true. What do we want? We want 4 and 7 to be congruent. So we have the green information and we want the black information. So we're going to use things that we know. We're going to try to tie 4 to 7. We're asking ourselves, the things we know, are they related to the things we want? Is 4 related to the parallel lines or angle 5 or angle 6, the green things? Is 7 related to the parallel lines or angle 5 or angle 6? Those are the questions that we're going to ask. Let's focus right here. Yes, angle 4 and 5 are related. We know because of parallel lines, right? If I trace the parallel lines, the armpits of the Z, we know 4 and 5 are the same size. Those are alternate interior angles. So, we have all the given stuff. I'm not going to rewrite all that. That's given. But angle 4 and angle 5 are congruent. That is something that we understand from the parallel lines. What is that called? That is the alternate interior angle theorem. Yes. Okay. So now we have 4 is congruent to 5. Let's make a list of what we know. We know that 4 is equal to 5. They told us right here that 5 is equal to 6. So right now we know that 4 and 6 are the same size. We know that. We got that. But that's not the goal. The goal is 4 and 7. We're trying to get all the way to 7. Well, is 7 related to the parallel lines? No. Is it related to 5? No. Is it related to 6? Yes. Angle 6 and 7 are vertical angles. And this is from chapter 1, but we can say that angle 6 is congruent to angle 7. And that is just the definition of vertical angles. So now we can tack that on. Now we know 6 is equal to 7. So 4 is equal to 5, 5 is equal to 6, 6 is equal to 7, therefore 6 is equal to 7. That's what we're trying. Nope. Therefore 4 is equal to 7. I said that wrong, which is what we're trying to prove. So we now have it. Angle 4 is congruent to angle 7. How did we know? Technically, that is called transitive property. Is that an option here? So if you put transitive, it will count it right. I told you this year we're going to call it substitution. Either one will be counted correct, but that's the proof. What if we switched the order? What if we had done this second and this first? Is that okay? Could we have put that here? Yes. Those are not dependent on each other. Do I have to know 6 and 7 are congruent in order to know 4 and 5 are congruent? No. These are independent pieces of information, so it doesn't matter what order you do them in. But this requires us to know both of those things. This depends on both of those. It must come last. But there's our proof. Okay, next one. We got a lot of parallel lines. They don't always give us this many parallel lines, but we know that XY is parallel to Z dubs. So I'm going to go one color red. RS is parallel to TQ, or cutie, cutie. All right, so we got those. Parallel lines. Pink is parallel to pink. Red is parallel to red. One of the things I've asked you guys to do in class a few times is like, let's just forget the proof for a second, like angle 2. because of parallel lines. What do we know? Well, we know vertical angles are equal, duh. But if pink is parallel to pink, 4 and 7 would also be the same size. But we also know red is parallel to red, so 6 in this angle would also be the same size. And we also know that these are the same intersection because pink is parallel to pink, so we know that these are the same size. All of these green angles would be the same size in this picture. There's a lot of parallel line properties going on. So keeping that in mind, let's actually look at what we're trying to do. We're trying to connect 6 to 7. So I'm going to put that in green. 6 and 7 is the goal. Now, is 6 directly related to 7 in any way? No, 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 no. If I went to angle 6 and erased both of its lines, angle 7 is also gone. Angle 7 is fine. Angle 6 and angle 7 do not have a transversal. Right? Angle 6, if you trace pink and turn, you end up down here. If you trace red and turn, you end up here. At no point can you follow one of 6's sides and end up at 7. No. So you're trying to connect 6 to 7 with some friends. Do 6 and 7 have a friend in common? Well, if I start on pink and turn, nothing. What if I start on red and turn? Ooh, there's an angle up here. So if I trace angle 2 and I trace angle 6 and I connect them, what shape did I make? It looks like this. It's like an upside down F. Those inside corners are called corresponding angles and they will be congruent. So we know that these two are congruent. How about 2 and 7? Is there a path from 2 to 7? If I start on 2, if I start on pink and I turn, ooh, that's the letter Z. So yes, we got it. We got it. We got it. We know a few things. We know, well, actually, I forgot to fill in the blank proof. So we got all the given stuff. I'm not going to rewrite that, but that's all the given stuff. Then we know that angle 6, let's make sure it's an option. Yep, here we go. Angle 6 is congruent to angle 2. That is the corresponding angle theorem. Meow. Those are corresponding angles, and they use parallel lines. Remember what we said. The corresponding angle theorem is if lines are parallel, then corresponding angles are equal / congruent. Okay. Okay. And then we can connect 2 to 7, right? So we're at 2 now. So we started at 6. We're able to go to 2 corresponding angles. Now, if we go 2 to 7, those would be alternate interior angles. Angle 2 is congruent to angle 7, alternate interior angle theorem. So 6 goes to 2, 2 goes to 7. What does that mean? Angle 6 is congruent to angle 7, which is what we're trying to do. And that's transitive or substitution. I told you guys for this year, we're just going to call it substitution. Boom. So yes, you got to be good at handling those parallel lines. Oh man, I know it's hard, guys. I hope you're trying these before you're watching the video. Man, a lot of people are going to struggle. I know a lot of you are here for this question. And this question is tough. Something that I said a lot of times when we first introduced substitution was like if x equals 7 and y equals 7, if two things, x and y, equal the same thing, 7, what does that mean? It means that x equals y. If two things equal the same thing, then they are equal to each other. So every one of these proofs, it hasn't happened yet, but you're supposed to explain anything you know from the given. We haven't had anything to do yet, so I've kind of glazed over it. But like, we know something here. Look at this given. Ignore the picture. What do we know? So like we have the given statement. I'm not going to rewrite that, but that's given. Look real hard. We know that this is equal to 180. We know that this is equal to 180. If two things equal the same thing, what do we know? We know that the measure of angle 1 plus the measure of angle 4 is equal to what? The measure of angle 1 plus the measure of angle 5. Woo! It's like we're taking out 180 and we're plugging this in. Angle 1 plus 5 equals 180. Angle 1 plus 4 equals 180. That means 1 plus 5 and 1 plus 4 must be equal. have to. They have to. And that is substitution. That is not transitive. I take it back. Man, I'm speaking incorrectly. That actually is technically transitive if you wanted it to be. I don't know what we got here. We got subtraction. Nope. Substitution. Nope. Substitution. Where are you? I don't see substitution. Oh, there we go. There it is. Okay, now look at this. We're still not done with this. Both sides have angle 1. So could I say angle 4 is equal to angle 5? How do I get rid of angle 1? What do I need to do? If I did minus angle 1 from both sides, that would be a subtraction property of equality. Yeah. So we knew these were equal to each other because they both equal 180. We knew that 4 is equal to 5 because we subtracted angle 1 from both sides. We haven't even looked at the picture yet. But now we're kind of stuck. So let's look at the picture. We now know that angle 4 and 5 are equal. What does that mean? What does that mean? So guys, remember that like the alternate interior angle theorem says if lines are parallel, then alternate interior angles are equal. We don't know that the lines are parallel. We know that these angles are equal. So there's another theorem that says if alternate interior angles are equal, then the lines are parallel. That's what we have. That's part of what proofs are all about. What do I know? How do I know it? What do I know? I know that the alternate interior angles are equal. How do I know it? That was substitution, okay? What does that mean? Well, if the alternate interior angles, what does that mean? It means that the lines are parallel. So we now know that these lines, YZ and VU, we know that YZ is parallel to VU. So that's what we know now. How do we know it? It is the alternate interior angles converse. When you know angles are equal, or if this is what we know, if you know the conclusion first, that is the converse of the theorem. So if the original theorem requires you to know lines are parallel, the converse would conclude lines are parallel. Basically, these things switch places. That's what a converse is. What do you know and how do you know it? We know the lines are parallel. How do we know it? We know it because the alternate interior angles are congruent or equal. That's the converse of the alternate interior angle theorem. Yeah, that's tough. That's tough. That's the last one. All right, guys. Love y'all. Thank you for working so hard every day.